Alright, so we are in the Jupyter notebook and I'm using Visual Studio Code and I've added the Jupyter extension to it. You can use whatever you like, Jupyter Lab, Anaconda, etc. So before we begin our analysis, let's take a look at the league table for the 2020 and 2021 season. We can see Manchester City were the champions during that season, and Manchester United were the runner-up, and Liverpool and Chelsea made it to the top four. And if we look at the relegation part, we can see Fulham, West Bromwich, and Sheffield United got relegated. So let's see if the stats for these particular clubs show us anything. So I've already added the questions like that I'm gonna explore with the visualizations. So let's start with importing the relevant libraries. As I mentioned before, we'll be using matplotlib, seaborn, and as well as plotly express as a visualization libraries. Again, these are very common, like the most common used visualization libraries used in Python. So let's import. First of all, we need something to read the data, so we're gonna import pandas. Let's see, pandas as pd. Import matplotlib.pyplot as plt, and then let's import seaborn as sns. And one more thing is plotly.express as px. So we're gonna run them and see. Okay, they're good. So next what we're gonna do is we're gonna read the data set. So I'm gonna define my data set as data. Maybe you can name whatever you like. So I'm gonna use pd.readcsv. As it's a CSV data set, the format for the data set is CSV, so this is the format. So I'm gonna use pd.readcsv, and then I'm gonna add the name for the CSV file. So it's EPL 2020 CSV. And now let's check the head of our data frame. Data.head. Maybe let's see the top 10 rows for the dataset. So again, this dataset is pretty straightforward. So these are the stats of each player from each club for the entire season. We can see we have the name of the player, the club they belong to, nationality, what kind of positions they play in, what's their age and how many matches they played, how many starts they got, what's the total number of minutes they were on the ground, total goals they scored, assists they had, passes attempted, and so on and so forth. It's a self-explanatory data set, and it's pretty clean as well. So we won't be doing a lot of data, I would say, wrangling and data cleaning in this video. So I'm gonna check quickly on the stats for the data set. Let's see, I'm gonna transpose this. Yeah, I'd like to read this way better. So we can see age, we have someone really young to someone at the age of 38. If we see the minimum and the maximum ages, the matches they played and the maximum number of matches they played. So the entire season comprises of 38 matches, so someone played all the 38 matches as well. And I'm gonna quickly check on the missing values. I'm pretty sure there are no missing values, as this data set is pretty cleaned up. So I don't see any missing values. We can see non-null for all of the columns that we have. So let's take a look at our first visualization. What does the roster looks like across the club? So how many players each club has as their squad. So before I do that visualization, I first need to count the number of players. So as I mentioned, this data set has the player as a one record, so we'll be just doing a count of each club, and then that will give us the total roster count for each club. So I'm gonna do club counts. So our data frame now, it needs basically a column, so we need the counts by the club and do a value count function. So this will basically count our data frame and club counts. Let's see. So we got by each club what are the total counts, total number of players they have. So now I'm gonna quickly plot this, and what I need to do is, first of all, I'm gonna set the size of the figure of the visualization. So I'm gonna do plt.figure, the fig size, so maybe 12 by 6, and then next I'm gonna add a bar plot to show the distribution. So I'm gonna use seaborn as of now, seaborn dot bar plot. So the bar plot takes the data frame, the x value and the y value as the required attributes. So first of all, the data is our data frame, and the x-axis is the club counts. Actually, I've already counted them, so I don't need to mention the data frame. I can do directly on the x-axis. So I'm gonna do club count dot index to be my x-axis, and y should be the club counts values. And let's set the palette as well. So I'm gonna say where it is. Okay, so let's quickly check what our plot is showing us so far. So if you can see, okay, the axis and the labels are pretty squished up. So I'm gonna add a rotation to the x labels. X sticks, rotate them to 90-degree. Rotation equals to 90-degree. Okay, that's pretty well aligned. So we can see West Bromwich Albion has the highest number of players, to be 30 in their squad, and Leeds United have the least, and that's not like really low, but it's 25, close to 20, 23, 24. And now I'm gonna quickly format the chart as to add the x-axis and y-axis title and the title of the whole chart. To do that, I'm gonna again say plt dot x label. X-axis is our club, and plt dot y label. Y label is number of players, and the title, let's name the title as player distribution across the club. Player count across the clubs. Okay, all right. Oh, we spelled across wrong. Okay, so we have the title, the labels x, and the y labels. So next, let's take a look at the distribution of players' age across the club. So we need to know what distribution on the age each club has. So I'm gonna again add a histogram here. So histogram gives us a great distribution analysis. So before doing that, again, obviously I'm gonna set the size. So I'm gonna set it to maybe 10 by 6 this time, and then sns.histoplot, it's histplot. Data, again I'm gonna pass the age, as we're gonna do the distribution on the age, so it needs to take a column, so age, and I'm gonna add bins to 20, so it's gonna divide the distribution into 20 bins, and KDE true, and then maybe I'm gonna color it by sky blue. And then next, let's quickly take a look at the chart. oops, we did something wrong. Bin, it should say bins, not bin. We can see we have lesser number of players that are less than 20 years, and also less number of players that are more than 33 years old, and it's a Premier League football highly. So we can, the age between 20 to 30 is more likely the players will be. Next I'm gonna format it quickly to again add the X labels. And then add the Y label, age and number of players, and the title, player age distribution. Okay, so this is now summed up for the entire data set, all the clubs. What if I want to break it down by each club? For that, I do have something really cool that I'm gonna show. I really love using facet grid as seaborn's facet grid. I use that often in my work as well to show a lot of time series analysis for each of the categories. So let me show you how that will look like. So to do that, it's a sns.facetGrid as a function. I'm gonna add a variable g as an object to get the visualization. So facet grid needs the data frame that we want to use. So the data frame is data. Next we need to define the number of columns that we want to the column that we want to display the data for. So I'm gonna say club, and don't worry, it will make more sense once I visualize this. So we need to break it by the club. So we're gonna add club as a column, each club as a column, and I'm gonna wrap those column to say like 5, and then share y-axis as false, and share share x-axis as false, and hue the club by the club, hue the color by the club, and aspect as 1.5. So if I quickly now I'm gonna map our object to tell us that use histogram as the plot for this facet grid, and age bins as again maybe 10 this time because we're breaking it by the club, and add the KDE to be true. Okay, oops, I forgot to end the parentheses here. Okay, let's see. Okay, there's a parenthesis. Okay, so let's see how that will look like now. It will take time. Okay, so we can see now we have a beautiful grid where each column is a club of its own, and we have the distribution by each club regarding the age. As we can see, by each club you will have different sort of distribution, obviously, because every club will have different age group. So but most likely we can see the age groups between the player is more on the 20 to 30 bucket, and less on the youngster side, and on the age after 33 or something. And then you can obviously do a lot of exploration here and do analysis by each club and how the distribution is, but most likely at a high level we can see they are more normally distributed between 20 to 30 years. So next, take a look at again the same thing but with the player position, what sort of positions the player likes to play, and they are distributed among each club. So again we're gonna do the similar kind of things, but again I'm gonna add the figure to say fig size maybe 10 by 6 again. So sns.countPlot, I'm gonna add the data frame then I'm gonna add, I need it by position, so I'm gonna add on the x-axis I need the position. Then on the I need to order the position by the if you need to order the position by the value counts, you can add something like this: order, then the data, your data frame, and then the column, and dot value counts dot index. So this will basically add an order to your value counts. And this time I'm gonna add a pastel palette, pastel 1. So let's quickly see. Okay, so we can see the distribution of the positions across all clubs. We can see most clubs has defenders as like higher count versus midfielder, forwards, and there are obviously there's gonna be very highly less likely a chance where a player will play as a forward as well as a defender. So we can see there's quite few people that can play with both of those positions, but most likely they will have a designated position of their own. We can see defender, midfielder, forward, and there are like hybrid player which can play forward as well as midfield. Again, you can explore however you like. Again, I wanted to show you how distribution and count plots can be done in the using Seaborn. Again, we can, if you want to do the distribution by each of the club and see the player position by each club, you can do similar kind of thing, just like we did on using facet grid. So I'm gonna do a facet grid, and this time I don't need the histogram, but I need the count plot. And I'm gonna quickly add position as so I don't need to order this one. So if I quickly run this, it will break it down by each club, and we can see as we saw on the aggregated graph that defenders are do have the higher number of players in each club. So we can see defenders everywhere. So next, let's see, create a scatter plot to show the relationship between the number of goals scored versus player age. So how likely a player will score according to their age. So to do that, this time I'm not gonna use Seaborn, but to show you how Plotly graphs looks like. And I really like Plotly graph because they are on the visual side, they are more likely visually appealing. So let's see. So this time I'm gonna name our visualization age versus goals. So px is the Plotly abbreviate we are using, px.scatter. So it needs the x-axis. So x-axis we're gonna add age. For the y-axis I need goals to see the relationship, and it says differently, they need the data frame. The data frame is our data, and now I need to add for each scatter, each dot on the scatter I will add a hover. So I'm gonna hover it by the name of the player, and also additionally I'm gonna add on the hover, additionally I'm gonna add sorry, I think this should be name, hover name, and this should be hover data. So hover data will have additional details on whenever you'll hover it over, and you will see once we run this visualization. I need club and the position they play in, and let's set the template to be Plotly dark, Plotly _dark. Okay, so let's quickly run this and see how this will look like. Once we say age goals dot show, okay, this is how this looks like by age and goals. Now I really want to see by the size of the dot to show me the number of goals the player played. So if I quickly do this size to show me, the bigger the size of the dot will be, the higher number of goals they scored. So I'm gonna just say goals size to be, and also I'll add a color to the goals. Okay, so let's quickly see. Okay, so now it starting to look really good. We can see the higher the dot is, the more goals they scored, and if you hover it over, you get the additional details for each of the dot. If you can see this dot, it shows Harry Kane had 23 goals and his age is 27 during this data set, and the club they belongs to and the position they play. And we can see quickly the players with higher number of goals tend to fall under the range of 25 to maybe 29, 25 to 28. And as you age, you're less likely to score, obviously, but there are players like Jamie Vardy that's like, he's a beast and he scores a lot of goals, and the less likely you're gonna score if you're past 35, except there are exceptions, Ronaldo, Messi, etc. So, and the younger you are, you'll most likely you're gonna get less playing time, and obviously you're gonna have less number of goals. So this is how a plotly graph looks like. This looks a little bit more visually appealing than the seaborn library, in my opinion. So I'm gonna just little bit do cleaning on the chart. I'm gonna add a title, age versus goals, and then add title x to be 0.5. Let's see. Okay, age versus